Look at this spatula. Just a regular tool, mix and spread ingredients, right? But wait, this one is floating in space for some reason. So there's this astronaut named Pierce Sellers. There he is. He's up there in space, just doing his thing, when all of a sudden, he accidentally drops his trusty spatula. Let me give you some context. This all happened during the Space Shuttle Discovery's STS-121 flight back in 2006. They were on their way to the ISS on a mission to test out some new safety techniques. And now this spatula is just a tiny drop in the ocean of space debris. Humans have been exploring space for over half a century now. We've left all kinds of random stuff up there, from itty-bitty bolts to entire space stations. We've chucked a ton of things into the great beyond. Most of it burns up in a spectacular blaze as it re-enters Earth's atmosphere. But some bigger pieces can be a real danger for astronauts and their fancy spacecraft. Imagine accidentally crashing into a massive hunk of space junk. There are other weird things found in space. In November 2008, astronaut Heidi Stefanishan Piper was out on a spacewalk trying to fix a jammed gear on a solar panel. Suddenly, she lost her grip on the bag. That bag weighed around 30 pounds and was filled with all sorts of cool stuff, like grease devices, a scraper tool, and bags for debris. And it was pretty pricey for a tool bag. It cost around $100,000. Sometime later, amateur astronomers spotted the bag floating around in space. If you're in North America, you can even check if the tool bag is passing through your little slice of the sky. Just hop on over to spaceweather.com's satellite tracker and see if you can catch a glimpse of this interstellar tool bag. By the way, if you need to twist some wires in space and you don't have pliers, well, you may stumble upon them as they're free floating in space too. Back in the day, when astronauts were just getting their space groove on, they tended to misplace things up there. During his first spacewalk on the Gemini 4 flight in 1965, Ed White, a famous spacewalker, accidentally let go of his glove. That glove decided to have its own adventure and hung out in orbit for a whole month before getting roasted in Earth's atmosphere. So not all debris is there to stay after all. So, space junk is basically all the stuff floating around in space that humans have left behind. Before we got all curious and started exploring, there wasn't any space debris hanging around. Imagine space junk as a little kid who just learned how to walk and play with their own toys. When they couldn't walk yet, it was easy for the person watching them to keep the play area clean. They were in charge of taking out the toys and putting them away. But now that the kids can walk, they can grab as many toys as they want and make a huge mess on the carpet. Well, it's kind of the same with us humans exploring outer space. We've sent all sorts of cool gadgets, like cameras, rovers, and rockets to check out what's out there. But we haven't really thought about bringing them back to Earth. And that's where the problem comes in. All this space junk floating around could mess up outer space, and even our planet. When we think about outer space, we often imagine vast open spaces that are yet to be fully explored. Humans have only discovered a tiny 5% of the universe. But here's something they might not always consider: the impact of all the cool gadgets they send out there. Believe it or not, as of May 2022, we've got more than 5,000 satellites orbiting Earth. Over 5,000 opportunities for these machines to go haywire, get lost in space, or even worse, create a bunch of debris that could harm both outer space and our lovely planet. There's at least 3,000 satellites just hanging around up there, not doing anything useful, and nobody seems to be bothered about bringing them back home. And what if one of these inactive satellites accidentally collides with one of the thousands of other space junk pieces orbiting our planet? It will result in a catastrophic disaster. We're talking about a crazy release of toxic substances that could wreak havoc on our poor Earth. Space junk can mess things up for scientists trying to make important discoveries. It's not just floating around aimlessly in space or posing a threat to Earth. It can hinder their chances of success. Even the moon has its fair share of junk, which Neil Armstrong definitely didn't encounter when he landed there in 1969. Think of it like this. Imagine you're an artist trying to create a huge painting. It's hard to do that if there's a bunch of old paints, brushes, and other stuff cluttering up your play area, right? Well, it's the same deal for scientists trying to set up camp and use new technologies for advanced missions and space exploration. They need a clean and organized space, just like you need a tidy work area. Otherwise, it's chaos. So here's the deal with space junk. It's not just about sending stuff up into the atmosphere. It's also about how far away we send it. You see, when satellites are sent over 22,000 miles into the atmosphere, it becomes a real problem to retrieve them and bring them back to Earth. And that leads to even more space junk floating around up there. Now, I know what you're thinking. How long will it take for space junk to become a major problem? Well, it might still be a few more years before it messes things up in outer space. But hey, that doesn't mean it's not a threat to satellites we have up there right now. Those poor guys are at risk of getting damaged, destroyed, or even leaking toxic stuff because of all that junk. So, space debris isn't just a problem for space exploration, but it's also a problem for us Earthlings, even though it's floating thousands of miles above us. Space junk is like that annoying neighbor who throws trash out their window and it ends up in your backyard. Except instead of trash, it's releasing all sorts of chemicals into our atmosphere that are slowly destroying our precious ozone layer. It can even ruin future space missions. Imagine this. You're all pumped up to launch a rocket into space, but nope, space junk decides to crash the party. Not only does it mess up the launch, but it also adds more pollution to our already struggling atmosphere. And if things couldn't get worse, imagine a shooting star or meteor accidentally smacking into some space junk on its way to Earth. Boom! Millions of toxic particles raining down on us, further depleting the ozone layer. Plus, space debris is becoming a real problem for space missions. In 2022, we found some space debris hanging out on Mars. The Perseverance rover stumbled upon its own back shell just chilling on the surface of Jezero crater. They also spotted a random piece of a thermal blanket that might have come from the rover's descent stage. Also, human-made space debris actually smacked into the moon in 2022. It was probably some old rocket body from the 2014 Chang'e 5 T1 mission, but nobody saw that coming. It left a double crater behind. The more space junk we have floating around in low Earth orbit, the higher the chances of a cosmic collision. These collisions are no joke. They've already caused some serious satellite damage. Even the ISS has to constantly maneuver to dodge space debris. But scientists seem to know how to clean up this orbital mess. They're planning to send space vehicles armed with nets, harpoons, and even robotic arms to capture and deorbit all that junk. Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice. But these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone, the size of dozens of Everests, will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
What will the end of the universe be like? It might be 100 billion years away. But here's the real question. Should we start panicking already? Jan Levin, a cosmologist, appeared at a recent screening of the captivating Netflix documentary, A Trip to Infinity. She mentioned that there would be a time when the last sentient being exists and the last flicker of thought fades away. This perspective sheds a whole new light on things. Somewhere in the vast expanse of the universe, there will be a moment when the memories of legends like Einstein and Elvis will fade away. Just imagine what that last thought would be. A brilliant pearl of wisdom, a colorful expletive. The possibilities are as endless as the stars in the night sky. Now let's take a cosmic detour and explore how we got ourselves into this peculiar predicament. As we currently understand it, our universe burst into existence with a bang approximately 13.8 billion years ago. Since then, it has been expanding at an ever-increasing pace. For decades, astronomers debated whether this expansion would continue indefinitely, or if a big crunch awaited us in the distant future, where everything would collapse back together. Everything changed in 1998 when astronomers stumbled upon a discovery. The cosmic expansion was accelerating. This turbocharged expansion was fueled by a mysterious force called dark energy, woven into space-time's very fabric. The larger the universe grows, the more this enigmatic force pushes it apart. It's eerily similar to the cosmological constant, a concept introduced by Einstein to explain why the universe didn't collapse, only to be discarded later as a blunder. But guess what? The cosmological constant turned out to be a stubborn idea that refused to fade away. And now it poses a threat to both physics and the universe itself. If dark energy triumphs in the end, distant galaxies will eventually speed away from us so rapidly that we won't be able to see them anymore. With each passing moment, our understanding of the universe will diminish. Stars will extinguish and never ignite again. It will be akin to living inside an inverted black hole where matter, energy, and information are swallowed beyond the event horizon, lost forever. The star-making days of our universe are behind us. Star formation reached its peak nearly 10 billion years ago and has been gradually declining ever since. The reason for this waning of stellar light is our expanding universe. As the cosmos grows larger with each passing day, the matter within it remains constant but gets spread out over more and more volume. To create a star, matter must be compressed into relatively small volumes. As the universe ages, fewer opportunities arise for such compression. So, in the far future, we can estimate that the last star will be born approximately 1 trillion years from now. This final star is likely to be a small red dwarf, a fraction of the mass of our Sun. Red dwarf stars have extraordinarily long lives, slowly burning through hydrogen in a steady fusion reaction, but eventually, even they will exhaust their fuel. In roughly 100 trillion years, the last flicker of stellar light will fade away. This accelerated expansion will progressively limit our view of the wider universe. Although we can still observe distant galaxies because of the light they emitted long ago, their current light will never reach us. As the universe expands at an increasing rate, the boundary beyond which galaxies recede from our view moves closer and closer. One by one, galaxies will be torn away from us by the relentless cosmic expansion, accelerating so swiftly that their light will forever elude us. Anything not gravitationally bound to us will be unable to withstand this onslaught. Only the local group, consisting of the Milky Way, Andromeda, Triangulum galaxies, and several satellite dwarf galaxies, will remain in our proximity. However, this lingering existence will be far from idyllic. Over time, our 3 galaxies will merge into one megagalaxy, completely isolated from everything else in the universe. In this solitary state, the megagalaxy will slowly dissolve. Chance interactions will scatter individual stars, or what remains of them, into random orbits. Some will be hurled into the giant black hole at the center of the galaxy, while others will escape into the void, never to be seen again. After an unimaginable span, no complex systems will endure. All that will be left are isolated islands drifting in an infinite expanse of darkness. To make matters worse, as thinking requires energy, there will eventually come a time when the universe lacks the energy to sustain a single thought. Eventually, all that will remain are subatomic particles, dancing in the vast expanse of intergalactic space, engulfed by eternal darkness. This will occur trillions upon trillions of years after the last glimmers of light and life have vanished. And then, countless eons will stretch onward to the point where even measuring the passage of time becomes impossible. As Brian Greene described it in his book, Until the End of Time, it's a tale full of sound and fury, signifying nothing. This might make us feel some sort of weight of insignificance in the face of this cosmic destiny. If this truly is the fate awaiting the universe, it's both humbling and disheartening. Our universe may be 14 billion years old, but that's just a fleeting moment compared to the unfathomable darkness that lies ahead. It means that everything remarkable in our universe occurred in a mere blink at the beginning, followed by an eternity of emptiness, its finality and futility on an unimaginable scale. But hold on a second. Before we surrender to despair, let's remember that we're still a long way from this inevitable end. New discoveries in physics could provide a glimmer of hope, an escape hatch from this fate. Perhaps dark energy is not constant. Maybe it will change its course and bring the universe back together. Michael Turner, the brilliant cosmologist who coined the term dark energy, emphasized that the cosmological constant would be the least interesting answer to the dark energy puzzle. So, who knows what surprises the future holds? But for now, we can't help but peer into the abyss and wonder. We are but brief inhabitants of this cosmic spectacle, here for the grand party when the universe brims with life and light. We may not have a say in the final act, but we can cherish the here and now, reveling in the magic of the present. As astrophysicist and philosopher John Archibald Wheeler once said, the past and the future are mere fictions, existing only in the artifacts and imaginations of the present. From that perspective, the universe ends with each of us, granting us a unique perspective and a chance to make our mark. So let's embrace the fleeting nature of existence. Though the future may be finite, it liberates us to fully appreciate the wonders of this moment. After all, as the saying goes, nothing lasts forever, whether it's the stock market, the stars, or even our own lives. An awareness of eternity's whiff can illuminate the brilliance of a lifetime, even if it's just mine or yours. There is more than one theory about how the universe is going to be gone forever. In the world of quantum field theory, for example, we come across something called a vacuum decay. Picture it as a vacuum that's kind of stable, but not totally rock-solid stable. This false vacuum can hang around for quite a while, chilling in its semi-stable state. Could eventually say, nah, I'm done, and transform into a more stable vacuum. We call this wild event false vacuum decay. It's like a cosmic game of Jenga, where the unstable blocks finally collapse, and the universe finds its true balance. So, cosmic adventurers, let's treasure the Milky Way and all its splendor for as long as it lasts. And who knows, maybe in the vastness of this ever-expanding universe, there's still a surprise or two waiting for us. The story isn't over yet, and the cosmos is filled with secrets waiting to be uncovered. What do you think the end of the universe looks like for us humans? Are we even going to be around to witness it?